Okay, so let us start this. Okay, now till now we have completed all the problems related to motional EMF, Lenz law. Like we didn't have actually discussed what is called as motional EMF, but we have done something related to that. Okay, you'll see how Lenz law we have completed, and before that all these numerical problems we have completed. Got it or not? So I think you should just practice once more to try to understand this. Basically, Lenz law, there will be questions based upon that. One questions will be definitely over there. Now, tell him fast. The main time only. Yeah. Okay, what do you know about motional EMF? Any idea? Huh? Hey, what? Guys, what is motional EMF? Tell one person at one time. Can you tell me what is motional EMF? You have studied now? In your board classes, do you have studied or not? Little bit about it, you have studied. Okay. What used to happen? Let's suppose if you have a current, if you have a magnetic field, and in that magnetic field, if I have some kind of conductor which is moving with some kind of velocity v, what used to happen? Something was developing over there or not. So basically you might not have studied how the charges develop, which charges will develop, and which kind of polarity of charges are going to develop on the ends of the rod. You have studied basic phenomena, but here we are going to develop all the mechanism of this motional EMF. So let us consider this is our conductor. Okay, we have one conductor, right or not, one rod. Okay, and this rod is of length L, right or not? So this is given. So you have this rod, particular rod, which has length how much? Length L is given. Now this rod is placed in which plane? XY plane. Rod is placed in which plane? XY plane. Perpendicular to this XY plane, I have put one magnetic field over here. Okay, which is going upwards. Means the what is the direction of magnetic field? It is equal to B naught Z cap. You can say something like that. Right or not? Are you able to get me or not? Now, what we are doing is actually we are providing the velocity to this rod. This rod is kept in XY plane. Okay, mainly on the X axis, you can say, right or not? Okay, if someone asks you what is the equation for this rod, can you tell me? What is the equation for this rod? Let's suppose from origin, this distance of this rod is considered at, let's suppose D. So what is the equation of the rod? Can you tell me? Can I say X is equal to D is the equation of rod? X is equal to D. Look over here. For every point on Y, okay, so sorry. Yeah, look over here. If you see the X axis and if you see the Y axis, if you see over here for the rod X axis and particularly Y axis, what is happening over here? This rod is kept at this distance D on the Y axis or not? Tell me yes or no, right or not? For every value of X, let's suppose if X is equal to 1, what is the value of distance D or not? Tell me yes or no. For the, let's suppose if X is equal to 2, at what distance this particular rod is kept? Is it kept at 2? No, no, it is not kept at 2. It is kept at distance D. Got it or not? So therefore, X is equal to D, you can say, for the rod. Can I say like that? Let's suppose if you have, okay, just tell me one thing. Let's suppose this is X axis, this is Y axis. Okay, what is this equation? What is the equation of this straight line? Tell me, what is the equation? Okay, if let us start from this way. Let's suppose if this is the line, this is Y, this is X. What is the equation? Y is equal to X. This is the equation or not? So here, tell me what will be the equation? At what on the axis it is kept at, let's suppose 2. Let's suppose it is kept at X is equal to 2. So what is the equation? Okay, for perfectly Y axis, what is the equation? X is equal to 0. For X, what is the equation? Y is equal to 0. Yes or no? Perfectly X axis and perfectly Y axis. For perfectly Y axis, what is the equation? X is equal to 0. For perfectly X axis, what is the equation? Y is equal to 0. Now, is this line is parallel to y-axis, got it or not? So equation should be in terms of x, got it or not? So equation in terms of x means what? What will be that? X is equal to 2. If you check for every point on y, you are getting x value how much? 2. So therefore this line has an equation what? X is equal to 2. Got it or not? If the line is parallel to x axis, you will write in terms of y is equal to 2. Got it or not? Any variable you select on x axis, for that, what is the value of y? Always it is 2. Got it or not? Yes or no? Are you able to get me or not? So here, is this line is parallel? Okay, is this line is parallel to what? X axis or not? Tell me yes or no. So therefore, what will be the equation? It will be y is equal to distance d. What will be equation? Y is equal to distance d. This line is parallel to the x axis or not? Yes or no? Select every variable of x. Select this x. For that variable of x, what is the distance of y? Y is equal to d always. Got it or not? Are you able to get me or not? Is this okay? Hey, the nurse. What is this equation? X is equal to d always. Got it or not? Okay. I'm erasing this. Should I erase this? Understood or not? So you have the magnetic field B is equal to B naught J cap, and the equation of this conductor as Y is equal to D. Got it or not? Y is equal to D is the equation of this conductor. Now this particular rod is moving with some kind of velocity V. So what will happen? What will happen? That this distance between the rod is going to change or not? Tell me yes or no? Or yes or no? So what you will get? You will get dy by dt is going to be called as, let us call this as velocity. So we are going to say that as the particle conductor starts to move, the y-axis amount is changing. Therefore, we get the equation. The variation of y with respect to t is going to be what? Velocity of the conductor. Right or not? Yes or no? So let us move fast. Hey, actually, check. Somewhere I lost my watch. Okay, I kept in somewhere. You just check it where I kept in the class or what. No, so you just check in chamber, Professor Chamber. Okay, because I went there one day and I think I have opened it and I kept this table now. When you go now, check it. Okay, now look over here. So now look over here. If this conductor moves with velocity v, magnetic field is perpendicular. What will develop in this conductor? What is changing? Is the flux is changing or what? Is the flux is changing? Huh? No, na? Is the flux is changing? What is the area of rod? What is the area of rod? What is the area of rod? 0 or not? What is the area of rod? 0. If the area does not change, then how come the flux will develop? Flux is what? B dot ds. Huh? You have to make some area. If the area is itself 0, there will be no flux in it. Right or not? Very less amount of flux is there. Okay, through the area of cross section of this particular wire over here. Now look over here. If you have rod which is moving at velocity v inside the magnetic field, then what it is going to experience? It is going to experience some kind of force, and that force will be given as what? Force will be equal to B into, sorry, force will be equal to V cross B, and there will be a constant K. Got it or not? How much will be the force developed? Constant K into V cross B. Now the question is, what is this constant K is going to be? What is this constant K is going to be? Now, this force, this particular force will be experienced by which quantities? This force is going to be experienced by which quantities? Tell me. The charges over here, look over here. See, first of all, magnetic field is there, movement is there, and force is getting generated or not. So should I use right hand thumb rule or left hand thumb rule? Tell me first. Right hand thumb rule or left hand? Or left hand or right hand? When force is generated? When force is generated? When force is generated, left hand. When current is generated, right hand. Right or not? So now look over here. If B, I. B is inside. Velocity is towards this side. Where is the force generated? Upwards. So all the charges over here are going to feel some kind of force due to the magnetic field, and this constant is replaced by some kind of charge over here, which we have studied in magnetism, which is equal to QV cross B. Right or not? Yes or no? Is it clear or not? So now look over it. Where the charges are experiencing the force, they are experiencing the force in the upward direction or not? Tell me yes or no. If they are experiencing the force in the upward direction, what will happen? Charges will start to move from point P to Q or not? Or yes or no? Now, which charges are easier to move? Electrons or protons? Which charges are easier to move? Electrons or protons? Are electrons only, na? In metals, what is present over there? Free electrons or protons? Free electrons. So which charges will move? Electrons will move. Now look over here. Electrons will move where? The question is that now. Now tell me. Electrons will move where? Upwards or downwards? Upwards or downwards? Okay. Look over here. If the electrons are there, so this what will be the force equation? F equal to minus of E into V cross B will come over there or not? Tell me yes or no? Yes or no?
Sure.
Now, if minus is coming, that means what? Net force is downwards, right or not? So where the electrons are actually moving? Electrons are moving from Q to P. But if you consider positive charges like protons, okay, protons will move from P to Q, right or not?
Sure.
That is why the Q is attaining which polarity? Positive polarity, and P is attaining which polarity? Negative polarity, right or not? Is this clear or not? Every concept. So look over here. For the electrons, this is the equation. The electrons are experiencing the force minus of E V cross B. Negative sign is shown for opposite direction. Right or not? If it is proton, F will be Q V cross B, which I will be applied. And therefore, if I consider plus sign over here, then protons should move from P to Q. If I include negative sign over here, then electrons should move from Q to P. Right or not? Is this clear or not? Write this fast. Hey, chache, choti chachi. Shreya is Amma of everyone. Yes or no? Yes, sir. Oh, HM on the last. Which day we say? Which day? Last day of what? Farewell. Okay. We'll award Shreya with the award of Amma. Can we move ahead? Now look over here. Okay. Hey, force on the charge particle. Listen, force on the charge particle is also given as charge Q into electric field E or not. Tell me yes or no. Yes or no? Force on the charge particle is what? Charge Q into electric field E. Now, here electric field is not generated. I am asking, see, previously electric field, from the initial way electric field is not present. Hey, Dhanush, look over here. Electric field is not present. What we are saying is, when this conductor is there, when it is experiencing force due to this magnetic field, go it or not, due to this magnetic field, since there is a movement of charge particles, what will generate? One extra electric field will generate or not? Tell me yes or no? Or yes or no? When there is positive charges created over here, there is a negative charges created over here. Net electric field will be generated over here or not? Tell me yes or no. And this electric field will apply some kind of force on these electrons only, the internal electrons which are present over there. I call this the electrons or protons as E value, and this is equal to what? Minus of E V cross B. So what will cancel? This minus of E got cancelled, and electric field you have got is how much? V cross B. If the velocity is undeflected, what is the equation? Electric field is equal to what? V by V cross B. Yes or no? Or yes or no? Now look over here. Now try to see. Does the electric field is equal to potential difference potential difference divided by length? We have done now. Let's suppose if you have two equipotential surfaces, Okay, this is at potential V of A, and there is another equipotential surface down of it. Okay, right or not, which has potential difference V of B. Right or not, the distance between these two Y is how much? D over here. The distance between these two potential differences means this equipotential surface is how much? D. So electric field was given as what? dV by dr or not? Tell me yes or no? Or yes or no? Which will be what? V of A minus V of B divided by D. Right or not? So now look over here also. What is happening? Here positive charges are there, so consider it is V of Q. Here P is there, so consider it is V of P. Between this electric field is generated or not? And between these, how much from this to this potential, how much is the distance? Length of the conductor L, right or not? So therefore, what I got as equation, electric field is equal to V of P minus V of Q divided by length L is going to be how much? V into D. Velocity into magnetic field, right or not? So how much is the net potential difference developed? Net potential difference developed is nothing but V, sorry, L V cross B. Right or not? Is this clear or not? So if you have a straight current carrying a straight conductor which is moving with some kind of velocity V inside a magnetic field, the amount of potential generated across the ends of this conductor, amount of potential generated across the ends of this conductor is given as VLV. Right or not? Or yes or no? Now the point is simple. If this particular length of conductor starts, let's say this is my magnetic field. Okay, and in this particular length of this conductor starts to move with some kind of velocity which is making angle theta. Okay, here it is not making angle theta, still it is 90 degree only. Okay, because magnetic field is along the z axis, velocity is along the xy plane, right or not? So z axis and xy plane always makes with respect to each other how much degree? 90 degree. If they are making, if the conductor velocity of conductor starts to make angle theta with the magnetic field, the potential difference changes to blv sin theta. What it changes? BLV sin theta. Where theta is the angle between, remember that, angle between velocity vector of conductor and magnetic field. Write this fast. Did you have written or not? Do it fast. Do it fast. Should we do like this? Like for the study hours, Imran sir and Siva sir will come 2 days. Okay, 1.5. They will distribute their timetable, and I will come only on Saturday whole from 5:30 to 10:30. It will not be completed. It's not good idea.
Sir, mark is from 3 days to full. We don't have.
Can we move ahead? Can you move ahead or not?
Sir,
Okay. Right on. So now look what I see this. This is what it is saying. In a steady state, the total. Let's suppose if the electric field is if the electric here induced electric field. This is what it is saying. In a steady state, total force is what? It is equal to, let's suppose on a charged particle, what will be that? QV into V cross P or not? Or yes or no? Force, Lorentz force tells what? If you have a charged particle and there is electric field and there is a magnetic field, what is the force on it? Q E plus V cross P or not? Tell me yes or no. But this electric field is induced electric field. That's what I said. Look over here. This force says due to this particular magnetic field, there is a force of magnetic field which is generated over here on the charge. Now these charges, since there is a difference, potential difference which is created, due to this potential difference now what will be created? Electric field will be generated. Now this electric field starts to affect these charges, right or not? These charges when they are getting affected by electric field, they generate the current after that, Got it or not? Is it okay or not? Is this clear? So this is what it is saying. So look over here, if you have induced electric field inside it, it is going to be equal to how much? It will be equal to minus of V cross B. Got it or not? How much that will be? Minus of V cross B. Got it or not? Now electric field is what? It is simple. Look over here. Electric field is nothing but potential difference divided by length L. So it has considered, let's suppose if you have a smaller element dl, on this smaller element dl, you have the potential, net potential difference is what? Minus of integral E dot dl or not? Tell me yes or no? Or yes or no? So from where to where? From P to Q. Actually, look over here. Where is the, in P, this is my positive or not? This is my negative. But here we are doing the integration from P to Q downward. That's why it has negative sign over here. Got it or not? Is this clear or not? So therefore net answer is what? Integral B cross B dot dl. Got it? Is this okay or not? Yes or no?
Sir.
There is a cross product and there is also a dot product. Got it or not?
Sir.
Okay. So this is what it is saying. As a particular example, let us consider a straight rod of length L moving with speed V in uniform magnetic field, cutting the lines normally. So therefore, induced EMF is how much? It is equal to VLP. Got it or not? Okay. Remember that what it is written in a steady state. What is this steady state? In which state? Steady state. Remember that steady. Why we are using the word steady state? Hey, listen. Steady state means charges inside that are not moving initially. Initially, there was no current inside the conductor. Got it or not?
Sir.
Is this okay or not? Chandro, pore. We'll plan for couple dance for Chandro. Farewell. Chandra. You'll remember it, Chandra. Oh, my physics sir was there. Okay. Then they will plan for marriage. Then they will plan for kids. Huh? Chandru, can we move ahead now?
Sir.
Okay. Moving to next point. Today 9 to 10:30. Okay.
Sir.
Hey Ranga, do not talk.
It's not like we thinking it's too much.
Thinking.
Sir. It's not like our thinking is too much.
Can you move ahead?
Sir.
Okay. Now look over here. Now what we are saying? Hey, hey, Manasa, be silent. Now look over here. This time, similar case is there, but now instead of moving with velocity v, we are rotating this particular rod with angular velocity omega. Got it or not? With what velocity we are rotating? Angular velocity omega. Got it or not? Or yes or no?
Sir.
So now if we are rotating this particular rod with angular velocity omega, the question is, what will happen with the EMF? What will happen with the electric field? Can you comment on that? Tell me. Can you tell me something about this or not? So look over here. If it starts to rotate with angular velocity omega, okay, first of all, let me just try to say something about this thing. Let's suppose if a particle is moving in a circular motion, if a particle is moving in a circular motion, right or not? Tell me what are the first, how many kinds of velocities are there? How many kinds of velocities are there? Two: velocity, tangential velocity, radial. Right or not? Yes or no? How many kinds of acceleration are there? Two kinds: acceleration, tangential, acceleration, radial. Right or not? Yes or no? Yes or no? What is the equation of velocity? Then it is equal to, look over here. What is the equation? Net equation? R omega r cap. Yes or no? Omega r cap plus a. r omega r t cap plus dr by dt r cap. What is the equation of acceleration? Omega square r cap plus alpha r t cap plus, means you can use extra term that will come, right or not? This is the equation. What does t cap represent? Tangential direction. What does r cap represent? Radial direction. This r cap means what? Direction along the radius. T cap means what? Direction along the tangent. Right or not? Yes or no? These are the equations or not? I'll do it once again. Circular motion I'll do once again. I'll revise you guys all of these things. Got it? Yes or no? Okay. We have to do all of this. Should I erase this? Write the equation, write these equations. First complete this equation. Chachi, are you able to understand? Just Miss Chachi, are you able to understand? Can we move ahead? Now look over here. If it starts to rotate with angular velocity omega, this particular, let us, means if I want to calculate how much EMF is developed over here in this whole rod, which is rotating with angular velocity omega, we do not know. Like, do we know that where we have the formula for EMF is what? BLV, right or not? Or developed EMF is equal to what? Integral V cross B dot DL. Why it is taking DL then? Means if in some condition, if the length starts to varies for a smaller length, if the particular condition, if the velocity is different, what will happen? You will have different EMF. Now look over here, when you are considering this, select one dx over here, select one element over here, the radius is very small, right or not? Now actually for magnetic field we need to select what? V perpendicular or not? Tell me yes or no. Now V perpendicular in this case, which is rotating with angular velocity omega, is what? It is equal to omega into r or not? Tell me yes or no. Or yes or no? V tangential, which is going to be omega into r, right or not? There will be two components of velocity, one V into and one V radial inside, right or not? But since this V radial is actually lying along the conductor, what it will give? It will give the zero EMF or not? Tell me yes or no. So only V tangential is going to give you what? Net value of EMF. Now V tangential is what? Omega into r. As the radius is going to change, what will change? EMF is going to change or not? Or yes or no? Now, if I have considered one element nearer to the particular center of rotation, EMF will be very much less over there. If I consider a little bit far, EMF will be different over there. So that is why we are doing that. Let us consider we have some kind of element. We have one length element or current element, which has length how much? Its length is equal to dx, right or not? And it is located at distance x from the center of rotation, right or not? If we calculate the particular potential drop across this dx, we can integrate it from 0 to length L and we will get the total EMF developed over there, right or not? Or yes or no? So now look over here on this dx, what is the velocity? The velocity is equal to how much? It is equal to this velocity perpendicular is going to be how much? It will be equal to velocity tangential, which will be how much? Omega into r. Got it or not? Or yes or no? So therefore, now this radius is going to be x or not? Tell me yes or no. This radius will be equal to x or not? Why? Because this element is lying at distance x from the center of rotation. So therefore, net EMF developed is going to be how much? Integral V cross B. V is how much? Omega into x into magnetic field into current element. What is the length of the current element? What is the length of the current element? Dx or not? Tell me yes or no. Into dx. How much you got? From 0 to L. If you do it, you will get the answer B omega L square by 2. So how much is the EMF? Let's suppose this is point P, this is point Q. So therefore potential at P minus potential at Q. I think this is that. Okay. So, yeah, potential at Q minus potential at P, higher potential to lower potential, it is going to be equal to how much? B omega L square divided by 2. Is this clear or not? Yes or no? Is this clear? Okay, okay. Can I move ahead? Did you have written or not? Can I move ahead?
Sir.
Or yes or no?
Sir.
Next. Do this question. What is saying? There is an square loop ACDE, okay, of area how much? 20 centimeter and resistance 5 ohm. Hey, Dhanush, look over here. Is rotated in magnetic field of magnetic field is equal to how much Tesla? 2 Tesla through 180-degree in 0.1 second and in 0.2 second. Find the magnitude of EMF, current, and charge in both of these cases. Tell me how much will be the answer? Hmm. Why they are making so much noise, yaar? Huh? Dance class. They're learning dance. Let us also go learn dance. Next month, what? Chandru will dance. Correct. Now you said, guys, correct. We'll make the Chandru dance. Hey, we have to complete so many things in EMI. Please do it fast, okay? Tell me how much will be the answer? There are more questions which I collected. Hey, do not talk. Guys, look over here. Area is given how much? 20 centimeter. Resistance is given how much? 5 ohm. Is rotated in the magnetic field of magnetic field how much? 2 Tesla through by 180-degree. Okay, if I rotate by 180-degree, tell me where this A will go? Okay, this is my square loop, right or not? A, C, E, D. Got it. This angle is how much? 0. Rotate it by 90-degree. Where it has came A, C, and this is D and this is E or not? Tell me yes or no. Rotated by furthermore 90. A has came over here or not? C is over here and E is over here and D is over here or not? Tell me yes or no. So if you rotate it by 180-degree, what is going to happen? This point C will become A will become C, this will become D and this will become E. Got it or not? Or yes or no? Now, if you check over here, magnetic field is inside or not? Magnetic field is inside or not? For that magnetic field, look over here. Uh, I want to know the EMF, I want to know the current, I want to know the charge. If you are rotating it, what is happening? EMF means area is getting changed or not? Tell me yes or no? Or yes or no? So first of all, can you calculate the flux? First calculation should be what? First calculate the flux. Can you calculate the flux? Tell me. So first, what is the formula of EMF? EMF is equal to minus of d phi by dt. Got it or not? Are yes or no? So now look over here. Can you calculate flux initially? How much is that going to be? So look over here. For A, C, D, normal will be upwards or not? Tell me yes or no? Magnetic field is inside or not? How much is the angle between normal and the magnetic field? How much it is? In initial case, how much is the angle between the normal and the magnetic field? Uh-huh. How much it is? 90. Magnetic field is inside, normal is upwards. How much is this angle? Array, this is my particular plate. Magnetic field is inside it. Normal I can draw like this way or not. How much is the angle? Normal between normal and the magnetic field? 0 degree or not? If you rotate it by 180 degree, what will happen? This normal will come outside and it will become how much? 180 degree. Either you can consider at initially case 180 degree and finally it will become how much? 0 degree. Got it or not? Both of the case angle are going to be just changed. Got it or not? So first case I am considering it to be 0 degree. So how much will be that? B into area of a square, which is 20 into 10 to the power of minus 2. Got it or not? Into cos 0 degree. Got it or not?
Sir.
Or yes or no?
Sir.
Hey, here you write centimeter square. So this will become minus 4 over here. Got it? So therefore, phi final is going to be how much? Same magnetic field. Area is still remains same, 10 to the power of minus 4. But this has become how much? Cos 180 degree. Got it or not? So EMF in first case when the particular loop is being rotated in 0.01 second will be how much? Minus of phi final minus phi initial divided by how much? 0.01. EMF in second case in which time taken to rotate is how much? 0.02 is will be what? Minus of phi final minus phi initial divided by 0.02. Got it or not?
Sir.
Or yes or no?
Sir.
So can you calculate the particular EMF in both the cases? Or yes or no? Now current is what? In this case, current in first case will be what? It will be EMF by resistance R. Current in second case in will be what? In this case, this is E first, E second divided by resistance R. Got it or not? Or yes or no? Now, charge flown. Delta Q it is asking. It will be what? Current is equal to dq by dt or not? So charge will be what? I into time, which is here 0.01, and here charge will be what? It will be I into 0.02. I2 you will have to use over here. Here I1 you will have to use. Got it or not? Is this okay or not?
Sir.
Easy peasy or not?
Sir.
Okay. Can I move ahead?
Sir.
Can I move ahead? अरे yes. Yes, अच्छा. Are you able to understand? समझ में आ रहा है? नहीं आ रहा है? थोड़ा बहुत हिंदी बोलना सीखो तुम लोग, थोड़ा हमें आसान होगा. समझता है? हर्षिता? अर्थगता? अर्थ? आगुता? 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 अर्थ आगुता? Can I move ahead?
Sir.
Okay. Move to next question. This question is very important. Hey, what it is saying? That there are two conducting rails are placed perpendicular to each other. Two boyfriends are placed perpendicular to each. Sorry. One boyfriend and one girlfriend are placed perpendicular to each other, such that ends are joined by mobile phone. The conducting bar is now placed over the rails and start moving with constant velocity v. Okay, so this is my rod 1, this is rod 2. Okay, and hey, we have the conducting bar over here which is moving with velocity v at now. What it is saying that this particular rod starts at t is equal to how much? 0 from this vertex itself. Got it or not?
Sir.
Or yes or no? Find the flux through the triangle by the rails after time t naught. Find the EMF produced at in that triangle at that time. And in what manner does the EMF around the triangle vary with time? 3 questions. Do it fast. Can you do it? Hey, do not try to talk, guys. This question is very important. Okay. If you solve this, one Cadbury from today only, black current from my side. Extra black current, apart from teachers' day gift. Where is my teachers' day party, huh? I didn't believe you guys will do like this. Previous batch was good, huh? Do you remember it? This is called my best student. He remembered my birthday. Hey, hey, do this question. Not talk. Do this question. For you guys, there will be there. Today or tomorrow, definitely. Now look over here. What it is saying, first question, find the flux through the triangle isosceles by the rails and bar at time what t is equal to t naught. Right or not? Now look over here. You try to understand what is happening over here when the this conducting rod is moved from this vertex position to this position. Right or not? Wow, how it is done? So look over here. Try to see this. Okay. Rectangle. Okay, see this. So this is my rod. Okay, it was placed at the vertex over here. Got it or not? I'm moving it slowly. I'm moving it. What is increasing? See this. Initially, the area of isosceles triangle is very much less or not? Or yes or no? If I move it little bit more, area is increasing or not? Move it further, more area will increase further more or not? Move it further, more area is increasing or not? So does the flux is changing? So look over here. So there will be flux, right or not? And is this flux is dependent upon time also or not? Tell me yes or no. Dependent upon time. Why? Because look over here. Initially, let us consider it to be t is equal to 0. Let us start. Okay. So this is my t is equal to 0. Okay. At t is equal to 1 second, area is this much. At t is equal to 2 second, area is this much. As t is equal to 3 second, area is this much. At t is equal to 4 second, area is different. T is equal to 5, again area will become different. So that means what? If the area increases, what is happening? Does the flux is also going to change or not? Look over here. Flux is dependent upon area or not? What is the formula of flux? It is equal to V into A cos theta. So here normal will always make 90 degree. Sorry, normal will always make how much angles with the magnetic field? 90, 0 degree. Area we have to consider, not the straight rod. So therefore, what will be the answer? B into area A. Now this area is dependent upon sign, so you will have to write A into T. Got it or not? Or yes or no? Now it is your duty to find what is the area with respect to time. Do it. What is the area with respect to time? Okay, you will not be able to do it, I know. So let us bring this over here. Got it? It was over here. Listen me perfectly. It was over here. This rod, conducting rod, has came over here. Got it or not? Now divide like this way. Okay. Try to understand. Okay. Let us make. Wait 1 minute. Bring this over here. Okay. Let it be over here. Then you can do the calculations easily. Okay. So I'll bisect it. Got it or not? Now try to understand. Hey guys, listen me. if this angle is also, this angle is going to be 45 degree or not? Tell me yes or no. This angle is 45. Now if that is angle 45, look at this angle. This angle is going to be 90. Are yes or no? This is 90, this is how much? 45. So this angle will be also how much? 45. Are it 45 degree or not? So can you say if this angle is 45, this angle is also 45, two opposite angles are equal or not? So is this side and this side length should always be similar? Should always be similar or not? Or yes or no? Now if this rod is moved with velocity v, what will be this length in time t? Vt or not? Tell me yes or no. Distance will be what? Velocity into time. So is this length is also going to be vt in time t? Right or not? And this length will be also how much? Vt into time t. What is the area of the triangle? Area of, see here one area is forming or not? Tell me yes or no. Look over here, see this, try to understand this. Here one area is getting formed or not? One triangle is one isosceles triangle is getting formed over here or not? What is the area of this triangle? It will be equal to how much? S area at time t for the isosceles triangle is how much? Half base. Base is how much? Twice vt. Yes or no? So twice Vt into height. How height is how much? Vt. So look over here. 2 got cancelled. How much you got? Area Vs square Ts square. So area as a function of isosceles triangle over here is how much? Vs square into Ts square. Right or not? Is this okay or not? Look over here. If velocity is 0, how much will be the area? 0. So therefore, did you got the flux with respect to time t? How much is that? B into Vs square Ts square. How much is the flux with respect to time t? B into Vs square Ts square. Right or not? Or yes or no? What it is asking? Find the flux through the triangle by the rails at t is equal to t naught. Did you got your flux at t is equal to t naught or not? How much is that? So therefore, flux at t is equal to t naught. That is how much? B into Vs square into t naught square. Is this okay? EMF is what? Therefore, EMF is what? Minus of d phi by dt. So how much will be that? Minus of 2b into v square into t naught. Yes or no? Yes or no? Differentiation of, sorry, ts first I'll do for ts square, then I'll put t is equal to t naught because it is asking EMF at that time only. Right or not? So then it will become 2 minus of 2 v square into t naught or not. Tell me yes or no. Correctly I have written that, sir. Is it okay? Are you okay or not? Rakshita, okay or not? Write this fast. I think it is correct. Yes, twice v square, you know. Okay. Now if you apply the modulus over here, this will become what? Positive. Okay. Many answers will be given in positive. Okay. Okay. To write the NEET exam, just like previous guys, how many papers, which papers you have to complete? Mention from 2005 to 2013, 7 papers. 7 paper physics of JEE mains you have to complete. Which paper? JEE mains. Alright, listen. Because that are repeating. 2014 question has came in 2021 and 22. 2014 and 15. Right or not? And 2009 whole about 5, not 30%. 2009 30% of the question was in this paper. 2020 30% question. Right or not? So solve from 2005 to 2015 at least. 10 papers. I'll give the printout. Okay. 10 papers, JEE mains 2005 to 2015. And have you seen two versioning and all? I have given one WBJE papers. Yes or no? WBJE papers. I have given them already. I told them to complete that and ask Prithvi. She have written many questions got matched from there and even concepts. Got it or not? So you have to solve at least 5 previous year WBJE form. How many papers you have to solve? 5 plus those 10. 15 papers you have to solve definitely before NEET exams. For physics, if you want to really get good marks in physics, okay. And apart from that, if you are solving previous year for NEET, that is also better, okay. 2005 to 2015 JEE mains and WBJE main 2015 to 2020, right or not? 2015 to 2020, if you solve, that is enough. That is too much enough, okay. So multiply, how many questions will be there? In JEE mains, 30 questions are only there. Okay. So it will be around 30 into 10, 300 questions from there. And in WBJE, I think WBJE 40 questions are there. Okay. So 40 into 5, 200 questions. Total 500 questions. Okay. Solve it from right now only. Okay. December month. Okay. Can I move ahead? Okay. Wait. In what manner does the EMF around the triangle vary with time? Can you tell me? What it is saying? In what manner does the EMF vary around along with the time? If you just do not put T is equal to T naught, the EMF formula will be what? It will be equal to minus or plus 2 VV square into T or not? Tell me yes or no. Can we say that does the EMF is directly proportional to time or not? Or yes or no? How it is getting varied? If someone asks you what is the variation, that means what? What he is asking? He is asking about the graph, right or not? So how does the EMF varies with respect to time? How it will vary? EMF is directly proportional to time or not? So therefore, does it will vary linearly? Yes or no? How it is varying? Linearly it is varying. Got it or not? Is this okay or not? Okay. Can I move ahead little bit? Huh?